Hello, welcome. And we're going to work on the chapter 5 review today. So let me go ahead and share my screen. And it's actually the chapter 5 review from the book, page 485. It looks like this. So let me write that down, page 485. And so these first set of problems, 1 through 8, are all about reducing each rational expression to lowest terms. So in order to do that, we have to factor. Okay, so you're really going to have your factoring down. So I can't factor anything out of the top. So 42 common factors are 6 and 7. So I'm going to just take a guess and hopefully this is right. 7, 6, and 7. And maybe that'll work because 14x squared would be a 2x and a 7x. So hopefully the numerator and denominator has something in common there. 49 and 4. So 14 and oh, okay, yep. So if we do 7, it's going to have to be a negative. So it's going to have to be a bigger 49. 7 times 7 is 49 minus 4 would be 45. Oops. Would be 45. So it's 2x plus 7 and 7x minus 2. So hopefully this is a 7x minus 2 up here. So if that's true, this would be minus 2, and this would have to be 5. So 35 and a negative 12. So positive 35 and a negative 12. So those simplify, and we have 6x plus 5 over 2x plus 7. Ooh. It's kind of tricky. Okay, let's see here. So down the bottom, because there's only 2 terms, this has to be a difference of squares, if anything. And so 4 squared makes 16 and 3 squared makes 9. So this could be 4x minus 3, or sorry, 4y minus 3x times 4y plus 3x. And so up here, so 6x squared, it's going to be a 3x and a 2x, I think. And then 12 is 2 and 6 or 3 and 4. You just have to crisscross just to make a 1 right here. So 3, no, so 4 and 3. Okay, how about the 4 and 3? Because this is an 8, 4 and 2 is an 8, and 3 is a 9. We need the 9 to be bigger by 1 for the middle. So this is going to be positive and that's going to be negative. Okay. Oh, and this is y, 4y and 3y. Okay, so this is the opposite of the denominator, 3x minus 4y and 4y minus 3x. So we could factor out a negative here from the bottom and make this a 3x minus 4y. So then this and this cancels. So we're left with a negative just our little negative hanging out. And then we've got 2x plus 3y over 4y plus 3x. I think that's all there. Number 3, we've got a difference of squares on top. So y minus 3, y plus 3. And then a sum of 2 cubes on bottom, and the sum of 2 cubes is on our factoring flowchart, which you can use on the exam. And the factoring flowchart says a cubed plus b cubed right here. A plus b, so y plus 3 times y squared plus 3y plus 3 squared, so 9. And so these, the binomials cancel. So we're left with y minus 3 over y squared plus 3y plus 9. Okay. Number 4 and 5 are still simplifying. So x plus 3 over x cubed plus 27. So this is the denominators. The numerator does not factor at all, but the denominator is the same as what we just had factored in the last denominator. So x squared plus 3y plus 9. So the x plus 3's cancel, so we're left with 1 over x squared plus 3y plus 9. And number 5, 2x and x. And then the only way to make a y squared is a y and a y. So this is going to be 2xy and xy. And they both need to be negative, so they multiply to make a positive y squared. Okay, and then we have just 2x minus y in the denominator, so those cancel, and we're left with just x minus y. And then number 6. After that, so a 3x and an x, because there's 3 terms we know there, and then this one's going to be 3x and an x. In the numerator, we need a difference of 4. So we're going to have to do 2 and 2 because 4 and 1 won't work. So 6 minus 2 is 4, and we need the 6 to be a negative, so that's going to have to be the positive. So a negative 6 plus 2 is a negative 4. And then we have 3x times x, and then the negative 2 is going to be, we need it to be a difference here. So the 2 has to go here, so it's 3 and 2. And the 3 is going to be negative, and the 2 is going to be positive. So it's going to be a negative 3 plus 2 is a negative 1. There we go. So it looks like the 3x plus 2 cancels, and we're left with x minus 2 over x minus 1. Seven and 8 are asking us just to simplify each. So we're going to have 2x plus 3 minus 2a plus 3 over x minus a. We could factor out a 2 from these, and you have x minus a And then you have this plus 6 on the end over x minus a. So minus 2a and a minus 3 right here. So that actually adds to 0. Okay. So our x minus a's cancel and we're left with just 2. Okay, number 8, I'm going to distribute again properly here. So we have x squared minus 2x. Distributing the negative, we have a minus a squared and then plus 2a all over x minus a. So the minus 2, oh, that's x and a, so no. So from the first two, we have an x, and then we have an x minus 2 left over. And then the second two, we have a minus a, and we have an a plus 2. Well, that's not going to work. Think about this here for a minute. So if we group the x squared and the a squared, so it's x squared minus a squared minus 2x plus 2a. We could then factor this into x minus a, x plus a. So x minus a, x plus a. And then if we factor out a negative 2, so minus 2, we'll have an x minus a. So we actually have an x minus a in common. And then we have an x minus a minus 2 left over. And then the denominator is just an x minus a. That's a tricky one. So the x minus a's cancel, and we're just left with x minus a minus 2. That was tricky. Okay, number 9 and 10 are asking us to find the domain. And the domain only has to deal with the denominator. So x minus 3 cannot equal 0. And so let's find out where it will equal 0, which is when x equals 3. So that means our domain is going to be a negative infinity up to 3, open parentheses, union 3 to a positive infinity. So it just has to kind of stop at 3 and then start back up again, because 3 is the only value it cannot equal. And then number 10, likewise, we can't have that t squared minus 25 equals 0 either. So if we factor that into t minus 5, t plus 5, and set that equal to 0, then we can use our zero product property, which says t minus 5 cannot equal 0, or t plus 5 cannot equal 0. So that means that t cannot equal 5 exactly, or it cannot equal a negative 5 exactly. So our domain's a little bit bigger. It's a negative infinity to the negative 5 union negative 5 to the positive 5 union positive 5 to the positive infinity. So we have 3 spaces, which we have just a hole at the negative 5 and a hole at the positive 5. Okay. Here. Riding a Ferris wheel with a diameter of 75 feet once around the wheel in 70 seconds. What is the average speed of the rider in feet per minute? Use 3.14 as an approximation for pi and round your answer to the nearest tenth. So they want to know this, what is the average speed of the rider in feet per minute? So they're traveling around 75 feet in 70 seconds. So 75 feet in 70 seconds is, they wanted it in this average speed per minute. So we just need to change this into minutes. So there's 60 seconds in 1 minute. And so if we multiply straight across, we get 75 times 60, so 4,500 over 70 times 1. And then we're going to divide 4,500 divided by 70, and we get 64. Oh, we have to find the circumference first. So we need to know our circumference equals 2 pi times the diameter, so that we know the distance that we're traveling around. So the distance is going to be 2 times the 3.14 times the diameter of 75. So 75 times 2 times 3.14 is 471 feet. Okay, so then we're going to take 471 and divide by 70. Okay, but this is 6.7288 feet per 1 second. And so this is where we have to multiply by the 60 seconds. The circumference is not 2 pi d, it's just pi d. I just thought of something that doesn't make sense. So my goodness, Mrs. Main, 3.14 times 75. Okay, so it's really 235 feet. Okay. 235.5 feet over 70 seconds. We can do this in one step, and then we're going to exchange our 60 seconds for 1 minute so that we have feet per minute. That's what we're going to do. So we are going to do 235.5 times 60 divided by 70, and we get 201.86. 201.86 feet per minute. Okay, finally got that. So 14, the rest of the problems are mainly 14 through 22 are going to be multiplying and dividing. So catch me back for that video.